Pseudo multivariate calculus. We are in phase of it's a kind of historical discussion that can we how we mold our problem, how we mold our problem into a kind of a calculus. If I have a problem, then how I can tackle the problem that later it will become a calculus. Most of the people they do not know that their problem is going to get solved through calculus. Okay, but everyone know that their problem is going to get solved through mere addition, subtraction, multiplication, and division. That everyone understand that how he can solve the problem through division, multiplication, subtraction, and addition. But people seldom they know that how they can tackle problem through calculus. That is the question that hits everyone's mind. Okay, like consider that I'm applying a consider that I'm applying a force. Okay, this is consider this is x-axis. This is x-axis, and there is an item here. Okay, there is an item here on x-axis. Makes sense? There is an item here that is kept on x-axis. Okay, now there is a force. There is a force along the x-axis only. Now it force is applied on this item for any distance. Okay. Now consider the distance is d1. So this item is moved d1 because of one force. Now there is another force is applied and it moved d2. Then another force is applied, it moved d3. What is the average force? Everyone would jump now. F1 into d1, force 1 into d1 plus force 2 into d2 plus force 3 into d3 by d1 plus d2 plus d3 is the average force. These are looks very simple, but this can be become a tedious in future. Consider that there is a force F1 applied for distance d1, then force F2 applied for distance d2, and force F3 applied for distance d3. If that is the case, then what is the average force that is applied? F1 d1 plus F2 d2 plus F3 d3 by d1 plus d2 plus d3. Okay, if that is the scenario, F1 d1 plus F2 d2 plus F3, this is called average force. Okay, now if this is not a repeated sum, we have discussed about average acceleration, average velocity. Now we will take one more stride, and then we will see average force. Average force. Now the force F1 D1 plus F2 D2 plus F3 D3. What is repeated addition? Repeated addition means if I'm adding 2 plus 2 plus 2 plus 2 plus 2 plus 2 5 times. Okay. Then it is called 2 plus 2 plus 2 plus 2 plus 2. 2 into 5. 2 into 5 is the repeated addition. 2 5 times if it is added, it becomes multiplication. 2 5 times if I add, it becomes 2 into 5. That becomes repeated multiplication. I'm sorry, repeated addition. Similarly, if I say F1 D1 plus F2 D2 plus F3 D3, if I say it is nothing but FIDI, 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 FID. What is your I? Consider now this can be expressed as a summation mark. There is a summation mark like I'm sorry, like this, this, this. This is summation mark. Okay, if there is a summation mark I equal to 1 to I equal to 3, FIDI. Now it is considered as a repeated sum. FIDI plus FIDI plus FIDI. It is repeated sum into three sections. Section 1 where F1 D1 is there, section 2 F2 D2 is there, and section 3 is F3 D3 is there. It is as good as FIDI into N. N is number of section. Makes sense? Fi into Di into N. Because it is repeated addition, right? N times, 3 times into 3 or N times. This is the net force into displacement. Fi into Di. F force. I'm not talking about vector. F means force. In denominator right hand side I. Fi Di N divided by Di. Okay, summation of Di. This is the average force. Now Di into N. Di into N. Di, that is D1, D2, D3, D1, D2, D3, Di into N. Di into N. If I say Di into N, okay, then it becomes D1 plus D2 plus D3. Di, if I say what is your energy calculation, that is force Fi into Di. Okay, that is for one section. Fi into Di, where I is either 1, either 2 or 3. Just taking I as a independent, I as a variable, Fi depends upon what is I. For any I, it can be first section, second section, third section, any I. If I take any I, then FIDI into N, one section force into displacement into N is the net force into displacement. If that is the case, then Fi into Di into N, Di into N, displacement of one section. We are talking about abstract mathematics. We are not solving a very specific problem, general problem. Okay, what is the net force into displacement? Summation sign, I equal to 1 to N Fi Di. Okay, it is same as Fi Di into N. What is N? N, this is abstract way. This is not the exact equal to. N is number of sections. Right now it is 3. Fi, force of any section. Di, displacement of any section into N. If I take second section, then again I have to multiply by 3. If I say take only third section, then again I have to multiply by 3. Any section, any I. Fi Di into N. Di into N is total distance. Abstract, man. How you can say total distance? D1 is different, D2 is different, D3 is different. If I multiply D1 with the 3, how it will become a total distance? If I multiply D2 by 3, that is 3 sections, how it will become to not possible? Take it possible. We are going for the repeated addition in abstract manner. If it is repeated addition in abstract, because we are repeating addition of FIDI, FIDI plus FIDI plus FIDI. Okay, where 1 is I equal to 1, 2, 3. But I'm not writing F1 D1 plus, because F1 D1 plus F2 D2 plus F3 D3 will never become F1 D1 into 3. Not possible. But if I say FIDI, then F1 D1 plus F2 D2 plus F3 D3 plus Fn Dn will become FIDI into N. Now Di into N will talk about the full distance that will become, that is become distance. So Fi into distance is the net calculation we are doing. Repeated addition F1 D1 plus F2 D2 plus F3 D3 plus F4 D4 plus Fn Dn. This repeated addition became multiplication. That is Fi Di into N, because it happened N times into N. Now this if I take N, N is variable here. N is variable here. Considering F1 and D1 as it is, N is variable here. Now, as per the calculus, if I am multiplying two items, what I am multiplying? Force FIDI with N. If I am multiplying two items and one is dependent upon another, it is candidate for the integral calculus. If it is candidate for the integral calculus, then fi di into n will become fi di fi di into dn. This is integral calculus. N will become dn. Fi di into n. N becomes dn, differential n. Now this is integral calculus. Fi di into n become fi di into dn. Now di is the distance of one section and n is number of sections. This if I multiply, then it becomes d of x if it is happening along x-axis from 0 to x. Now it becomes f1I into dx. The di and n I multiplied and it become independent component distance along x-axis. It becomes fi into dx. Consider this force is a function over x and indeed it is a function over x. Force in first section is different. Force in second section is different. Force in third section it is different. As we go along distances, force is different. Force is dependent upon x. So force I can write as a function over x. Now full become f bracket x into dx. Makes sense? See how we started and where we landed. Now the f1 plus d1 plus f2 plus d2 plus f3, I'm sorry, f1 d1 plus f2 d2 plus f3 d3 become f function over x, that is a function, that is a force, function over x dx, function over x dx. Okay, now this function over x dx, that is the net function into displacement divided by x, that is the total distance. This is average force. Can someone believe it like this? Okay, can you give one example? Consider force equal to x. Okay, this is x-axis. This is x-axis. I'm sorry. This is x-axis and this is origin. This is x-axis and this is origin. This is along the x-axis. Now, force, if I apply a force, force is growing in this fashion. The force is growing in this fashion. Can someone take example? I believe I had a spring earlier. Consider I tie a spring. A spring is okay. Some pen has a spring inside it, but I have to find that pen. Okay, okay. I have found one pen which has a spring. See? Okay, I'll try to take out the spring if it is possible. Hop, hop, hop. No. Okay, the spring is stuck here. Okay, I'll try another pen. Okay, I have one more pen, but I don't know if spring will come out or not. Oh, the spring is there. Okay, this is a spring. This is a spring. I can stretch this spring. See, I can stretch this spring. Now, consider there is a spring at origin, and if I pull this string, if I pull this spring, if I pull this spring, then it will come here. Now, it will, if I leave this spring, it will impart force. And force is directly proportional to the distance. When a spring is at rest, then there is no force, it is there. But if I pull it, or I can take a rubber, whatever it is. Okay, I have a rubber. So if this rubber, there is a rubber now. This rubber is at rest. This rubber is at rest. Now if I pull this rubber, okay, there is a force on the rubber. So if I pull this rubber, And then if I leave it, then it will go here. But here, as we go along, the force that it is showing, that is high. And here force is very high. If I leave it, the rubber will go back. Similarly, consider there is a force. There is a force here. Force is zero. This is origin and this is x-axis. Force here is zero. And as I go along, force is increasing. Force is function over displacement, certainly, because as we go along the displacement, force is different. Now, if I talk about the average force, can you tell me what is average force for a distance x? Now, force is x. What is the average force for a distance d on the x-axis? 0, comma 0 to d, comma 0, where force is function over x. If I try to calculate the force at point d, comma 0, then force is d. At point 3, comma 0, force is 3. What is the average force? That is the question mark. If I try to calculate average force, now I'll break into different components, and everywhere I'll try to calculate the force and multiply by distance. But force is variable. Every moment it is different. In that sense, calculus will come into the picture. What formula we applied, that if I break into, consider I break into infinite n, where one n is very small. Anyway, this is called modern calculus. Means if I try to calculate, let's not go through it. Whatever we talked about, that is pseudo multivariate. Pseudo multivariate calculus, it falls in primitive calculus. Primitive calculus means game of algebra. Rather than delta n tends to 0 and delta y tends to 0 and consider it is a straight line. Like if I break this 0 to d section into n part where n tends to infinity. Now if in one part that is delta n, that is very small, if I calculate the force in that region, it will be constant. These are hypotheses that I don't like. In that sense, for every section, force into displacement is force at that in that part, Fi, Fi di, Fi di, where I is the section number, where force is constant and di, Fi di plus F. So it will be summation of Fi di, where d is delta d. In that sense, it becomes f dx. This is a modern calculus. It becomes f dx. There is no mother and father of this approach. Okay, the primitive calculus what we are talking is f1 d1 plus f2. If consider that force is constant in one section, consider it is like that. I'm not talking about this example. Force is constant in one section. In that sense, f1 d1 plus f2 d2 plus f3 d3, if I divide into three sections, then it is summation of I equal to 1 to n fi di, fi di. In that case, I can also say fi di into n, considering fi di is the force into displacement of any section, where I belongs to any one of them. Fi di into n sections are there. This is pseudo multivariate. This is the pseudo code for the force into displacement. Fi di into n. Now this is multiplication of two item. Fi di multiplied by n. It becomes Fi di into dn, because multiplication will become integral calculus when one is dependent upon another. Fi di is dependent upon the section. So Fi di into dn. Now dn, n into di, if I see a number of section into di, altogether it makes the x-axis. It will become fi into dx. Fi is a function over x-axis, certainly, because as we move along distances, it is changing. Then fi will become function over x, fx dx. X is from 0 to d, what we are seeing. Let's try. Force over force, for how much force we are talking in this example. The force we are talking in this example is x. Force function is x. Force is force is changing as we go in the displacement. So if that is the case, then it becomes fx dx, x dx, x square by 2, 0 to d, d square by 2, divided by net resistance, that is d. D by 2 is the average force. D by 2 is the average force. If D is 10, then average force is 5. If D is 100, then average force is 50. If D is 20, then average force is 10. If D is 200, then average force is 100. Okay, this is the way we calculate the average force through pseudo multivariate calculus. Can someone imagine that how nicely we started with the force into displacement, and then we, or if someone is very smart in pseudo multivariate calculus, then he will say the what is average force? Average force is force into displacement by total displacement, where in the numerator displacement is variable and force displacement is independent and force is dependent. In that sense, it will become fx dx. Okay, displacement, force into displacement divided by displacement is the average force. Now in the numerator, force is variable with the displacement. This looks like displacement is independent component and force is dependent component. Displacement is along x-axis. Then I can say force into x by the net displacement. Now force into x will become force into dx. Force into x will become force into dx by total displacement. Force into dx, force is a function over the x, so it becomes fx dx, and x is from 0 to d by total displacement. This people can also understand, but the section approach is more generic because this is what anyone would think about. This is called pseudo multivariate calculus. People can tackle any problem. We started with the radioactive material also, where radioactive material disintegrate, it loses the mass. Any radioactive material, if someone keeps it, it will start losing the mass, it will radiate the energy, and one moment will come when it will become half of its mass. Any moment, if someone is calculating the mass, after some time it will become half of its mass. Then register the current mass and again see when it becomes half of the current mass. This is constant called half-life time period of the radioactive material. How to calculate a function where what is if I current time is 0 and I see the mass is x0, then any moment as a function of time, what would be the mass? Where change in mass per unit change in time is directly proportional to the what mass it is carrying. If mass is very high of the uranium, then disintegration of the mass per unit of the time will be bigger. If mass is very small, the disintegration of the of the radioactive material per unit change in the time will be small. Depend upon the mass. If mass is very high, it will shrink fast. If mass is very small, it will shrink less. The net amount that it is losing over a particular time will be less. If it is small, net amount that it will lose over a particular time will be more. If it is more. Okay, if that is the case, if that is the case, if that is the case, then what would be the formula of radioactive material? That is x by t directly proportional to x. Now x is function over t, it becomes dx by dt directly proportional to x becomes equal to kx. Now someone can solve it. Dx by, I'm sorry, it will be minus dx by dt equal to minus kx because it is decreasing. So dx by x equal to minus k dt. Okay, these are the division we please watch, I believe, previous video radioactive material. Anyway, now we know that what is the equation of average force. Average force is force function dx displacement function divided by the net displacement. Okay, that is the net force. Okay, now let's go with the more finery. Fine. The top part of this division is called energy. Force into displacement is called net work done or net energy divided by the net distance. Leave this denominator part. Only numerator part. Fx dx. Force, force, where there is no vector. Force is along the x-axis and displacement is also happening along the x-axis only. If this is x-axis and this is the force, then force is making this displacement. Still, energy calculation is not forced into displacement. Can you say it? It is forced into dx, where x is from 0 to d. This is the high difference from normal multiplication and integral calculus. If I say my force is x, if I move along x-axis, force keep changing. My force is x. Force is x. Then what is the net work done when displacement is 0 to d? In that sense, force is in direction of axis only. If force is x, then in a work done is force into displacement. The work done is force into displacement. If that is the case, the work done is force into displacement. Then force is x into x square. If it is 0 to d means d square, that is not the work done. If force is variable with the x, force into x is the net work done, and force is dependent upon x, it will become integral calculus. Multiplication, this is pseudo code. Force into displacement is work done. This is pseudo code. Anyone will write. If there is a force and there is a displacement along the same direction, what is work done? Force into displacement is the work done. Person will start from there. Now, force is a function over x, fx into x. Hope, there is some problem. This is not normal multiplication. Right hand side is x and left hand side of the multiplication is function over x. Force is varying. In that, it is not varying in the direction, it is varying in the magnitude. In that sense, multiplication of any two items where one is independent and one is dependent will transform into integral calculus. fx by x, fx by x, where numerator is a function over the denominator, the division will turn into differential calculus. Fx by x is not normal fx by x, it is dfx by dx. Fx into x is not normal fx into x, it is dfx into, I'm sorry, fx into dx. Okay, these are called, these are typically called abstract multivariate calculus. We started with the abstract multiplication and slowly transformed into, now consider that there is a force vector. There is a force. Now force has a direction. Earlier it was along the x-axis. There is a force vector, and because of the force vector, this is a force vector. Because of the force vector, one item is moving in a curve. Okay, there is an item. Okay, there is an item. Oh, okay, what is the item? Okay, there is a force like this, and there is an item like this. Okay, so idea is, okay, so the concept is that there is a force like this. The concept is that there is a force like this. Okay, so there is a force like this. There is a force like this. Okay, and item is moving like this. There is an item in this path. There is a path now. Okay, there is a force like this. There is a force like this. Okay, some force is there, hidden force is there. It can be my hand also, but there is a force like this, and there is an item, it is placed in a curved line. Now because of this force, this item is moving in the curved line. Make sense? There is a force, there is a force like this. Force vector is like this. It is in one direction. I can represent this force vector through real vector. Consider it is I plus j. The force vector is I plus j, means it has magnitude of a square root of 2, and it has direction I plus j, 45 degree from the I axis. There is a force like this. Because of this force, there is a there is a path like this. There is a path like this. Consider this is x-axis. This is path like this. Path is y equal to x square. That is the path. One item is kept at the origin, and because of the force, this item started moving along this line because of the force, and it come to point here where x equal to 4. If x equal to 4, y equal to 16. From origin, this moved and it came to a point that is 4 comma 16. From origin, it came to a point called 4 comma 16. Okay, if that is the case, then what is net work done? Force is I plus j. Force is I plus j, and item is moving in a curve where y equal to x square in xy plane. In xy plane, force is there I plus j. And then item is moving in xy plane only and in a curve fashion. Okay, y equal to x square. It is going from origin to point 4 comma 16. Then what is the work done? Force vector dot product with the displacement vector is the work done. If I take our pseudo mathematics calculus, then it is straightforward. Force vector dot length vector. Length vector is I plus dy by dx j bracket close into dx. If someone take it directly, then it will work. But what about right now the way we started another way of multivariable calculus? In the previous section, it was f into dx. If it is along the x-axis, can we proceed from there or we will take something else? What is force is? Force is fx I vector because it is along the I direction. Dx means dxi. F fxi dot product with dxi is the net work done, right? We can modify now. Earlier, we came to a conclusion that work done is force vector, that is function over x, into dx. Now, if I take full form vector, then it is force vector dot product with dxi. Force vector, luckily, it is in I direction, so fxi dot dxi that become fx dx only. Consider force vector in any direction, then it becomes f vector dot product with d of the vector of the direction, that is xi plus yj. Makes sense? This is called pseudo multivariate calculus. We started with the normal force into displacement plus force into displacement plus force into displacement to calculate the average force. Then we came to know that force into displacement for many sections we can write as force dx. Now we are coming to vector form. Force vector dot d of xi. If it is both are in I direction, that was hidden that I did not produce it. Fxi, that is the fx force function over x, that is the force. In the spring case, fxi dot product with dxi. Fxi dot product with dxi. Okay, that turned into fx into dx. If that is the case, then the force vector dot product with the direction, with the d of the direction is the net work done. Force vector dot product d of, now what is direction now? Direction is here, it is x-axis, but if we take full, then it will be xi plus yj because y will also come into the picture. It is not along the x-axis only. Then force vector dot product with d of xi plus yj. That is the network. Then we will proceed on this. This is called pseudo multivariate calculus. We start our problem for normal multiplication, addition, and division, and slowly we mold it successfully. We are trying to mold it into calculus and vector. Okay, so that we will see. Please do not mind supporting us. +91 is the India country code 9483160610 is the telephone number. +91 is the India country code 9483160610 is the telephone number.